Hello everyone. In this first topic, we're going to start with the introduction to NLP. So the essence of natural language processing lies in making computers understand the natural language. That's not an easy task though. Computer can understand the structured form of data like spreadsheets and tables in the database. But what about the human language, text and voices, which are like unstructured category of the data? So it is very hard for computer to understand it. Perhaps that is where the natural language processing arises. So there's a lot of natural language data out there in the various forms, and it would get very easy if computers can understand and process the data. We can train the model in accordance with the expected output in different ways. Humans have been writing for thousands of years. There are a lot of literature pieces available, and it would be great if we make computer understand that. How nice it is. But the task is never going to be easy. There are various challenges floating out there, like understand the correct meaning of the sentence, correct name entity recognition, correct prediction of various parts of speech, and many more. Don't worry, we're going to deep dive into each of these challenges. So if you didn't get anything about it, just wait a sec. We'll explore each of them. Computers can't really understand the human language. If we feed enough data and train a model properly, it can distinguish and try categorizing various parts of speech. Parts of speech in the sense the word in the sentence is noun, verb, adjective, supporter, and etc. So based on previous fed data and experiences. So if it encounters a new word, it tried making the nearest guess, which can be embarrassingly wrong few times. So it's very difficult for a computer to extract the exact meaning from a sentence. So to get it more, let's take an example. So if I write, the boy radiated fire like vibes. So what do you think about it? So from this sentence, what humans generally feel that the boy had a very motivating personality, or he actually radiated fire. So for humans, obviously it is going to be the first thing, like he is a very motivating personality. But for computer, it is very difficult to know that the boy is really motivating or he actually radiated fire. So perhaps that's the confusion which is arising for computer to understand it. So perhaps this is the one of the most complicated tasks in order to make a computer understand that this is not actually the boy radiated fire, but it is a perhaps a similar meaning to that a boy is very motivating personality or the boy is having a motivating personality. So basically there are various stages involved in training a model. Solving a complex problem in machine learning means building a pipeline. In simple terms, it means breaking a complex problem into a number of small problems, making models for each of them, and then integrating these models. A similar thing is done in NLP. We can break down the process of understanding English for a model into a small pieces. So it would be great if a computer could understand that San Pedro is an island in Belize district in Central America with a population of 16,444, and it is the second largest town in Belize. But to make the computer understand this, we need to teach computer very basic concepts of written languages. So let's start by creating an NLP pipeline. So the pipeline which we are going to create will have various steps, which will be for us to get the desired output. So in order to get the desired output, we are going to divide into series of steps, and we will look each of the steps. So the first steps which we are going to see is basically sentence segmentation, so which will break the piece of text in various sentences. If you didn't get it, let's take an example. So suppose if I input the sentence, the San Pedro is a town on the southern part of the island of Ambiguous Cay in the Belize district of the nation of Belize in Central America. According to 2015 mid-year estimates, the town has a population of about 16,444. It is the second largest town in Belize district and the largest in the Belize South constituency. Now the first step is sentence segmentation. Let me also mention it. Step 1 is sentence segmentation. So what the output will be is, so the output will be like this. Each part of the sentence will get break down into different piece of sentences. So the first piece of sentence will consist only San Pedro is a town on the southern part till Central America, and the second part of the sentence will be according to 2015 media estimates, and so on. The third part will be it is the second largest town in Belize. So this is how your each input is break down into series of sentences. Now for step 2 of a pipeline will be the word tokenization. So let me write it. Step 2, which is word tokenization. Okay, with the set. Before we jump into second step, let me give you a clear picture for this first step. Is like if for coding a sentence segmentation model, we can consider splitting a sentence when it encounters any punctuation mark. But for modern NLP pipelines, we have techniques to split sentence even if the document isn't formatted properly. So this is the important point which you keep in the mind. Now let's jump back to the word tokenization. So basically, what is word tokenization? So it is simple in terms. It's like breaking the sentence into individual words, and those individual words can be constituted as tokens. We can tokenize them whenever we encounter a space. We can train a model in that way. Even punctuations are considered as individual tokens as they have some meaning. Don't worry if you didn't get this, if you didn't get anything about it, we'll have a separate video only related to the tokenization. So there you will get a big picture of it. So again, if we take the same example of send, so I just copied. Okay, we have another. So we can have, like if we have a sentence like this, so we can have tokens as we mentioned at each respective word. So the tokens will be like San Pedro, which is a single word, will be considered as a single token. And another we have is can also be will be considered a single token. We have a, and so on. So this is how each word will be get to represented as a single token. So what we did is completed the entire sentence into different tokens, and this process is known as word tokenization. Now the third step is predicting parts of speech for each token. Like what all the tokens we have created now to determine like what part of speech each token belongs to. So let me write step 3, which is predicting the parts of speech POS for each token. So predicting whether the word is a noun, verb, adjective, adverb, pronoun, etc. This will help to understand what the sentence is talking about. This can be achieved by feeding the tokens and the words around it to a pre-trained model, which is a part of speech classification model type. So what this model will do, this model was fed a lot of English words with the various parts of speech tagged to them so that it classified the similar words it encounters in future in various parts of speech. So basically the POS model have been trained on the various words or various tokens and the associated the part of speech each word had. So it has related on those basis of words, and whenever in future we input the new sentence, so it will try to predict the part of speech for each of the respective word. So again, the model don't really understand the sense of the word. It just classifies them on the basis of its previous experience. It's pure statistics. So to understand it, the process will look something like this. So for example, if I input where's the town, so the output will be like the town will be considered as the common noun, is will be the verb, and the will be the determiner. So this is how each word has been associated with a respective part of speech, like town is with noun, is with verb, and the with determined, and so on. And this is how it will classify the entire text into various tokens, and each token will be associated with a POS. Now the step 4 will be lemmatization of the tokens we created. Lemmatization. Okay, spelling is correct. Okay, I'm running this code. Sorry, it's not the code, it's basically a text. Okay, just delete it. So again, as we will be looking for the tokenization, we will also have another video which is based on only on lemmatization. But for the simpler and for just an overview regarding it, what lemmatization does is like feeding the model with the root word. So for example, if we have there's a buffalo grazing in the field, and another example we are having there are buffaloes grazing in the field. So let me write and show you. So suppose we have both of these sentences. There's a buffalo grazing in the field and there are buffaloes grazing in the field. So here both buffalo and buffaloes mean the same. But the computer can be confuse it as the two different terms as it doesn't know anything. So we have to teach the computer that both terms mean the same. We have to tell a computer that both sentences are talking about the same concept. So we need to find out the most basic form or the root form or lemma, the another word for root form, lemma of the word, and it feed into the model accordingly. So in a similar fashion, we can use it for verbs too, like play and playing should be considered same. That is where lemmatization comes into play. Now we jump to the step 5 again. Now the step 5 will be identifying stop words. So basically there are various words in the English language that are used very frequently, like and, the, etc. These words make a lot of noise while doing statistical analysis. We can take these words out. Some NLP pipelines will categorize these words as stop words. They will be filtered out while doing some statistical analysis. Definitely, they are needed to understand the dependency between various tokens to get the exact sense of the sentence. The list of stop words varies and depends on what kind of output you are expecting. Now similarly, we jump to the step 6, which is dependency parsing. Okay. So what this means is finding out the relationship between the words in sentence and how they are related to each other. We create a parse tree in dependency parsing with the root as the main verb in the sentence. So if we talk about the first sentence in our example, then is the main verb and it will be the root of the parse tree. We can construct a parse tree of every sentence with one root word, which is perhaps your main verb associated with it. So we can also identify the kind of relationship that exists between the words. In our example, San Pedro is the subject and island is the attribute. Thus the relationship between San Pedro and is and the island and is can be established. So again, for this step, just like we trained a machine learning model to identify various parts of speech, we can train a model to identify the dependency between the words by feeding many words. Dependency in the other form, we can say like the relationship between different words. So it's a complex task though. In 2016, Google released a new dependency parser, Parse, which used a deep learning approach. So the step 6 basically divided into two parts. So if this dependency parsing is considered as the first part, I just write 1, and step 6 part 2 will be another important thing, which is like finding noun phrases. Finding noun phrases. So basically in this step, we can group the words that represent the same idea. For example, it is the second largest town in the Belize district and largest in Belize rural south constituency. Here token second largest and town can be grouped together as they represent the same thing, bellies. We can use the output of dependency parsing to combine such words. Whether to do this step or not completely depends on the end goal, but it's always quick to do this if we don't want much information about which words are adjective, rather focus on important details. Now the last step will be step 7, which is one of the most important step. Step 7, which is NER. In short, for the name entity recognition. Recognition. And also don't worry about this step because we will be seeing a detailed video regarding this topic. It is basically a major topic. So again, we'll just give you the overview of this. So San Pedro is a town on the southern part of the island of Ambergris Caye in the Belize district of the nation of Belize in Central America. So here the NER, which is the name entity recognition model, map the words with the real world places. So the places that actually exist in physical world, like in reality, we can automatically extract the real world places present in the document using NLP. So if we go with this San Pedro example and we look in this NER model, NER will map like this. So suppose I have, let me write it. So in the above example, if we only take the city's name, so what the NER model will do, it will map San Pedro to geographic entity, Ambergris Caye to again geographic entity, Belize to geographic entity, Central America to geographic entity. The basic purpose of NER model is to just map out the places or the text from the sentence into the real physical world, into the real physical entities, like in the real physical world. San Pedro is actually a place in the real physical world, so it will map the San Pedro word to that geographic entity, and so on. It doesn't only restrict to geographical entity. You can have many more entity recognitions. Some of them are, suppose you have like Google is the best company, so in that Google will be considered as an organization, so you can design your own entity recognition. You can even identify person, date, location, and many such things. So perhaps that is what NER model does. So NER systems look for how a word is placed in a sentence and make use of the other statistical models to identify what kind of word actually it is. For example, Washington can be geographic location as well as the last name of any person. A good NER system can identify this. So again, kind of objects that a typical NER system can tag is people's name, company's name, geographic locations, product name, date and time, amount of money, and any events. So yeah, that was all of it regarding the introduction to NLP. Now let's jump into the next video. Thank you.